Types of ink and their uses. Ink can be categorized by its application and composition. Here we survey major classes of ink, including writing inks, printing inks, tattoo inks, textile, dye-based inks, and various specialty inks. Despite differences, all inks generally consist of colorants, which provide color, and vehicles, binders, the liquid or matrix that carries the colorant. Additional additives, surfactants, dryers, preservatives, etc., are common to tailor properties. Below, we detail each category and examples of their formulations. Writing inks, pens and manuscripts. Modern writing inks are designed for pens and similar writing instruments. They must flow well, dry at an appropriate speed, and adhere to paper without feathering or clogging the pen. There are several subtypes. Fountain pen inks. These inks are water-based fluids used in fountain pens, which feed ink via capillary action. Fountain pen inks are typically dye-based, meaning the colorant is a soluble dye dissolved in the liquid. This ensures a homogeneous solution that flows smoothly through the pen's fine feed channels. Pigment-based inks would clog a fountain pen unless the pigment particles or extremely fine nanoparticle inks exist, but are specialized. A good fountain pen ink is free-flowing, non-clogging, and non-corrosive. Composition. Fountain pen inks are mostly water, the solvent, with a small percentage of dye, often on the order of 2–5% by weight of dye for strong color. For example, common dyes include eosin for red inks and various triaryl methane dyes, such as methyl violet or Victoria blue, for blue-violet inks. Black inks are usually mixtures of dyes. In addition to dyes and water, fountain pen inks contain a suite of additives, the vehicle components, to adjust performance, humectants, e.g., glycerol, ethylene glycol, to keep the ink from drying out too quickly in the pen nib, and to maintain moisture. Surfactants, wetting agents to reduce surface tension, allowing the ink to wet the pen feed and paper properly. Pure water has surface tension, 72 din cm. Fountain pen inks are adjusted to 38–45 din cm for optimal flow. pH modifiers to stabilize the dyes, since some dyes change color or precipitate outside certain pH ranges. Preservatives, biocides, to prevent mold or bacterial growth in the ink, since it's water-based. Sometimes anti-corrosion agents, especially if the ink has ingredients that might corrode metal pens, and anti-foaming agents for manufacturing. Historically, iron gall ink was used in fountain pens as well, especially in the early fountain pen era, 1900. Iron gall formulas give a very permanent blue-black line. However, they tend to corrode stainless steel nibs over time and leave sediments. Modern iron gall-based fountain inks, made by a few manufacturers, are formulated to be less acidic, balancing permanence with pen safety. Dip pen and calligraphy inks. Dip pens, including quills and calligraphy nibs, can use inks that are pigment-based or otherwise unsuitable for fountain pens. A classic example is India ink, also known as Chinese ink, which is a suspension of fine carbon black pigment, often lamp black soot, in water using a binder like shellac or gum arabic to help it adhere to paper. India ink is very black and permanent once dry, and since a dip pen has no internal feed, clogging is not a concern. Calligraphers also use pigment-based gouache or metallic inks containing particles like mica or metal powder for special scripts. These inks often have a thicker consistency and may contain gum arabic as a thickener and binder. Another common calligraphy ink is iron gall ink, as discussed, which dip pens can handle. These inks typically come in bottles and may need shaking if particulate matter settles. Dip pen inks can thus afford a wider range of compositions, including pigmented and fast-drying types, which would be problematic in a fountain pen, but deliver rich opaque lines with dip nibs. Ballpoint pen inks. The ballpoint pen uses a tiny rotating ball bearing to dispense ink. The ink for ballpoints is an oil-based paste that must write smoothly without leaking. Ballpoint ink is usually a thick, solvent-based paste containing a high fraction of dye for color and a mixture of chemicals to achieve proper viscosity in drying. A typical ballpoint ink contains about 25–40% dye by weight, a much higher pigment load than other inks, to yield strong color. These dyes are dissolved in a non-water solvent, hence oil-based ink. Common solvents in ballpoint ink include benzyl, alcohol, and phenoxyethanol, which blend with the dyes and evaporate slowly. The paste also contains fatty acids, like oleic acid, which serve to lubricate the ball tip as it rolls, ensuring smooth writing and preventing the ink from drying out inside the cartridge. A resin may be added as well to give the ink the proper consistency and to help it form a film on paper. Colorants. Ballpoint pen dyes are often basic, cationic dyes or acid dyes with high color strength. For example, the standard blue ballpoint ink uses dyes such as Prussian blue, Victoria blue, methyl violet, or copper phthalocyanine blue. These are bright synthetic dyes that, once the solvent evaporates after writing, leave a water-resistant mark on paper. Ballpoint ink, once dry, resists water, but can be dissolved by organic solvents like acetone or alcohol. Black ballpoint inks are typically a mixture of dyes, often including some of the blue-violet components plus others, to get a dark black. Red inks commonly use the dye eosin for the red coloration properties. Because ballpoint inks are viscous, they dry almost instantly on paper, largely by absorption and some evaporation. So they rarely smudge, a key advantage that Laszlo Biro exploited when inventing the ballpoint, inspired by quick-drying newspaper inks. The trade-off is that writing requires a bit of pressure to roll the ball and leave a mark. In recent years, low-viscosity ballpoint inks, so-called hybrid inks, have been developed, incorporating more lubricants and using medium viscosity fluids to provide a smoother feel while still drying fast. These are marketed under names like Parker QuickFlow or Uniball Jetstream, combining some attributes of ballpoint and gel inks. Rollerball and gel pen inks. Rollerball pens use the same ball mechanism as ballpoints but are filled with liquid, water-based ink, often very similar to fountain pen ink in composition. Because of the thinner ink, rollerballs write more fluidly and with less pressure than ballpoints, producing lines more akin to fountain pens. They do, however, take longer to dry and can smear, if not absorbed quickly. Rollerball inks are usually dye-based and may contain additives similar to fountain pen inks, wetting agents, etc., but in a more free-flowing formulation. Gel pens, by contrast, contain a gelled ink, a water-based gel ink in which pigment is suspended. The gel, often made with biopolymers like xanthan gum or acrylic thickeners, gives the ink a thicker consistency than rollerball ink, allowing the use of insoluble pigment particles rather than soluble dyes. This is why gel pens can offer vibrant opaque colors, including pastel, metallic, and glitter inks, that show up even on dark paper. Common pigments in gel inks are finely ground copper phthalocyanine for blue-green hues, carbon black, and iron oxides. The gel carries these particles smoothly through the pen and onto paper. Once written, gel ink typically dries by gel solidification and absorption. Many gel inks are water-resistant or fraud-resistant once dry, because the pigments don't redissolve easily. Notably, gel ink can resist chemical check-washing attempts, as the pigment won't dissolve in solvents like acetone, unlike some dye-based inks. Gel pens, first popularized in the 1980s, e.g., Sakura Jelly Roll, offer the ease of ballpoint, rollerball writing with the color intensity of pigments. They do tend to write in bold lines and can take a moment to dry, so smearing can occur if touched too soon. The follower, stopper, at the end of a gel pen refill, is typically a thicker gel plug that prevents the pigment from drying or backflowing. Printing inks, publishing and packaging. Printing inks encompass a broad class of inks formulated for various printing processes, from traditional presses to modern digital. Unlike writing inks, printing inks often need to transfer from a printing device to a substrate in a controlled way and then dry rapidly without smudging. They are typically more viscous and heavily pigmented than writing inks. The compositions differ by process. Letterpress and offset lithography inks, for books, newspapers, etc. These processes use plates or type that press ink onto paper. The inks are usually high-viscosity paste inks, not runny, to prevent flooding the page. A classic offset letterpress ink formula has pigment, e.g., carbon black for black ink, or various organic pigments for colors. Oil-based vehicle, historically linseed oil, a drying vegetable oil, or varnish, oil modified with resins. Modern inks may use petroleum-derived oils or soybean oil as the base. The vehicle is a viscous, slow-drying liquid that adheres pigment to paper. For example, soy-based ink, now common in newspaper printing, uses refined soybean oil as the base, mixed with pigment, resins, and waxes. The oil penetrates the paper fibers slightly, and then dries by oxidation and some evaporation, a process that can take hours. Resins and additives. Resins, such as alkyd resins, phenolic resins, or rosin, are added to bind the pigment and provide gloss and rub resistance once dry. Waxes might be included to prevent set-off, ink transferring to the next sheet, and to improve scuff resistance. Drying agents, dryers, often metal salt catalysts like cobalt or manganese compounds, can be added to speed up the oxidative drying of oils. Newspaper inks are a subtype of offset ink optimized for cheap, absorbent newsprint paper and high-speed printing. Many newspapers today use soy ink, which is more environmentally friendly than petroleum ink, lower VOC emissions. Soy inks deliver similar print quality, though they can be slower to dry. About 1/3 of American newspapers were using soy-based inks by the early 2000s. A typical news ink might contain a relatively low pigment load, since newsprint is porous and doesn't need heavy coverage, with a thin mineral or vegetable oil that absorbs quickly into paper, called cold-set inks, which dry by absorption. In contrast, heat-set inks, for higher quality magazines, etc., use a solvent vehicle that is dried rapidly by running the printed paper through ovens, then set by chilling, leaving a durable film as the solvent evaporates. Lithographic process considerations. Offset lithography works on the principle of oil-water repulsion. The ink must be hydrophobic and tacky. It typically contains an ink oil plus resin and is applied to plates where water-dampening solution is present on non-image areas. The balance of ink viscosity and tack is critical to avoid offsetting or emulsification with the water. These inks are formulated to stay on top of coated paper surfaces, yielding sharp images. They often make up about 5–30% pigment by volume in the ink, with the rest being vehicle and additives. Flexographic and gravure inks for packaging. Flexography, used for packaging like boxes, labels, plastic films, and gravure, used for high-volume printing like magazines, gift wrap, and also packaging, require low viscosity, fast-drying inks because these processes use flexible relief plates, flexo, or engraved cylinders, gravure, that transfer a thin ink film. The substrates are often non-porous, plastic, foil, or semi-porous, so inks must dry by evaporation rather than absorption. Thus, flexo, gravure inks are usually liquid inks based on volatile solvents or water. Solvent-based inks